All right, folks, so we're going to go ahead and get started. Welcome to our Masters of Education, Learning Design and Technology webinar featuring one of our new concentrations, Learning Engineering for Next Generation Systems. So again, thank you all for taking some time this evening. The session is being recorded and will be shared with registrants typically within 3 to 4 business days after the webinar. So I'm going to go ahead and just get started here. I won't take too much of our time. So when it comes to Johns Hopkins University, we are 9 divisions, 1 university. So on our screen here, you will see the 9 divisions, right? The Applied Physics Laboratory, Bloomberg School of Public Health, Carey Business School, Krieger School of Arts and Sciences, Peabody Institute, School of Advanced International Studies, School of Education, which would be us, School of Medicine, School of Nursing, and then Whiting School of Engineering, which our featured faculty member joining us this evening is a part of. So these are the 9 divisions across the university. Now, when it comes to the university as a whole, right, we're intellectually diverse. More than 24,000 undergrad and graduate students are enrolled in our 9 schools. We're driven by curiosity. So for 36 years, we've put more money into research than any other US academic institution. And then we're also globally focused. So you'll see that the university reaches into nearly every corner of the globe, conducting research, training, and related activities in more than 150 countries. But I do want to kind of just go a little bit more closer into the School of Education. So here at the School of Ed, right, we're, again, one of the 9 schools. Total enrollment is about 1,164 students. And within our portfolio, you will find 10 master degree programs, which we'll be talking about this evening, 2 doctoral programs, and then also 2 graduate certificates. We have across these programs 109 full-time faculty. We award annually 500 degrees, and we actually are just coming out of graduation this week. And then we have a growing alumni network here at the School of Ed of 27,000. And I do want to highlight that we're ranked in the top 20 best education schools by the U.S. News and World and Report. And then if you look at our profile in terms of our students, again, it will depend on the program, but generally across all programs, we cover 42 states, including DC and Puerto Rico, and 58 countries of citizenship. We do have 2 standout stats that you'll see there. About 32% of our student population are first-gen students, and then 30% are international. And we have kind of a nice even split when it comes to online versus on-campus enrollment. So you'll see about 55% of our students are online and 45% are campus-based. So specifically for this program here, the Masters of Education, Learning Design and Technology is online, but we'll talk about that here in the coming slides. But I'm going to go ahead and turn it over to Dr. Diamond, who will go ahead and introduce himself, and then we'll go into the rest of the program.
Thanks, Eliel. Hi, everybody. It's good to be here with you. I'm going to apologize in advance for my voice. I've got a bit of a cold and have had one for a couple of days, so I apologize for the scratchiness. I'm going to take a couple of minutes to give you a broad overview of the Learning Design and Technology program, and then I'm going to hand this over to my friend and colleague, Dr. Will Gray-Roncal, who I'll introduce in a minute. And Will is going to talk specifically about our new learning engineering concentration, which is likely what many of you are here for this evening. And Will go into some detail around the curriculum and our vision for the program and how we are thinking about learning engineering in this current moment in time. So I'm the program director for Learning Design and Technology here in the School of Education. I've been a faculty member at Johns Hopkins for 8 years. My background is in the areas of educational technology and instructional systems design, or even more broadly, digital media for learning. Before I came here to Hopkins, I was a research scientist at a nonprofit research and development organization called the Education Development Center. And for many years, I worked in a place called the Center for Children and Technology, where I did research and evaluation on the integration of digital technologies into K-12 teaching and learning. Until I came here and had an opportunity to take the leadership of this program and to begin to redesign our curriculum. So, a little bit of history. The program's existed for many years. It was called Digital Agent Learning and Educational Technology for most of its history. And then we paused the program and relaunched it last year as Learning Design and Technology. And I'll tell you a little bit about the concentrations as we go forward. And then, as I say, I will hand it off to Will. So, Eliel, if we can move forward, I think just a couple slides. I'll let Will introduce himself. So we'll come back. So very quick program overview, and as many of you likely know, you can find out a lot more about the program by going to our website. You'll find all the detail on the concentrations, what's being taught in the program, where people get placed professionally, and so on. So there's a very strong emphasis on practical application across the three concentrations in our program in the areas of instructional design, AI and education, data-driven learning, and so on. I won't read all these. You can see them. Um, we have a very strong emphasis, in addition to application, on reflective and ethical approaches. So in the program, you will develop a deep foundational knowledge of the learning sciences. So that is how human beings learn in different environments with different tools, in different socio-technical systems and settings. But throughout, what will be infused is this critical examination of how these tools are developed, how they're implemented, and how they're evaluated. And you'll ask questions like who benefits from the use of these tools and who does not and why? And who has a voice in how these tools get developed, implemented, and evaluated, and who does not and why? We have a big emphasis on leadership in this program. So you're developing practical skills in the areas of instructional design, AI leadership, and learning engineering. But we are also preparing you to become leaders in your field. And to do that, you need to build more than technical proficiency. You need to build more than hard skills. You need to be able to come up with visions, to think about the role of these technologies in different settings, to think about who they'll benefit and who they won't, to think about how to manage change in organizations when extremely disruptive technologies like AI come along. How will you manage change? How will you prepare the people that work with and for you to use this technology? How will you make decisions about whether to use these technologies? So these are questions you'll ask repeatedly throughout the program and across courses. Finally, we really are a very diverse community of learners. We have graduate students who come from many different backgrounds, many different geographical locations, and most importantly, who are bringing their professional expertise in all of these different areas into the application of the design development and evaluation of these technologies. Next slide, please, Eliel. So very quickly on program requirements, and then I'm going to hand it over to Will. So Learning Design and Technology is an online asynchronous master's degree program. There are 10 courses in the program, 2 foundation courses. All students take those courses regardless of their area of concentration. 2 methods courses, 3 concentration courses, 2 electives, and 1 capstone course. And so just quickly, if you look at the center column here, you see our 3 areas of concentration. So learning experience design is the concentration that launched last fall. These are the 3 courses. The other 2 concentrations that launched this fall are AI leadership and education, and the one that we're here to discuss and focus on this evening is actually learning engineering, not learning analytics. But as you will hear, we'll discuss, there is a very strong emphasis on learning analytics in the learning engineering concentration. And that's the last thing I'll say before I hand it off to Will. these two concentrations, they are extremely timely, AI leadership and learning engineering, right? And specifically learning engineering, what we now know, I think what all of us know, is that digital technologies are a complete part of education in almost every realm now. Almost all formal education and all learning that we do involves digital technologies in some form, right? And these technologies are very powerful. They can be very disruptive. They can bring some people in. They can exclude others. And what the learning engineering concentration, as Will is going to talk about, is specifically designed to do is to develop systems thinkers, is to prepare you not only to think in terms of instructional design, not only to think in terms of learning analytics, but to bring these skill sets together. So to be a professional who can think about the design, development, and implementation of instructional interventions, to prepare you to be a professional who can understand how to collect data, how to look for indicators of learning, and how to make decisions about what's working and what's not, and how to do that through continuous improvement cycles, such that you are constantly iterating, you are constantly improving tools, you are constantly thinking about the settings in which these tools are being deployed, and constantly thinking about how they are working for learners and how they are working for the institutional settings in which they're being deployed. So with that, I'm going to hand this over to Dr. Will Gray Roncal. I will hang around until the end. You may or may not have questions for me about the program. I'd be happy to answer them at the end. But with that, Will, please take it away.
Awesome. Thanks so much, Jim. Thanks for having me. Remind me how long I have to talk because we could talk about this really forever.
Absolutely. So I would try to give yourself 25, 30 minutes tops, Will.
Okay. No, that's great. And I love the idea of questions as people have them. Feel free to use the Q&A box, and I will try to integrate that in or ask at the end after I run through things. So now for my hardest trick, which is sharing things. Let's see what happens. Um, Always something. Okay. So I'm really excited to be here to tell you about oh, let me turn things on. See, this is what I'm saying. You can't see slides, but you can hear me. That's good. I was saying I had
And now we
recorded
can
lecture.
see you.
Yay! So I had a recorded lecture a couple weeks ago, and I literally talked for 2 hours, and there was no mic, so I was just sitting here talking to myself. It was not great. So you guys can see and hear me. We're good. Sweet. So really excited to be here to uh, talk about Lens. So this is our new specialization within LDT called Learning Engineering for Next Generation Systems. And so this is the product of I guess many dialogues over several decades. And then Jim and I have been in conversation for the last 6 years or so, thinking through some of these ideas and thinking about the engineering parts of this work and the learning analytics and the education pieces of this. Learning engineering has been around for decades, but really sits in an intersectional space and prepares you to solve problems that matter. And so I'll tell you a little bit about myself. So my Hopkins, as you may know, is a really big place, like 60,000 people. And so we have I'm gonna make a guess. I've been here for like 20 years. I think we have 15 question mark divisions. But everything from nursing and medicine that you might be familiar with to education and engineering, Peabody, which is music, uh, the international studies. I guess natively live at the Applied Physics Laboratory. And so we do lots of government contracting, anything from NIH to DoD. And then do lots of teaching. And so sit as a visiting assistant professor in the School of Education, where I've been working with Jim to design this concentration. I really enjoy teaching. I really enjoy helping people learn. I've had at this point hundreds of students. This is what happens as you get older, across pre-college programs and college programs and grad students and adult learners, thinking through a lot of these ideas of learning engineering and thinking about um, how do you make things work from a technical perspective, but the harder problem is how do you make things work from a human perspective? How do you actually make sure your systems are capable, and then how do you make everything work within that socio-technical system of everything coming together? um, and so my um, I guess engineering background is in lots of different things. I think engineering, much like learning engineering, is about tools in your toolbox. So I did my PhD in computer vision applied to computational neuroscience, where we map the brain at single synapse resolution. Um, I think if you're not doing agentic AI, you're just not cool. I was doing AI before it was cool, but that's fine. In healthcare domains, in defense domains, education domains, anything. I like to say anything from like underwater to outer space. And then again, lots in workforce development and thinking about the human. This is Julian. He is 6.5. This is his science fair project, and I think is a really fun example of like flywheel engineering and operating under constraints and solving problems. And so, I'm very determined to not be the dad that like does the science fair project for my kid. And so Julian had this. Um, use case, right? And he's like, when I'm at um when you guys have people over, there's like 30 or 40 people at your party, and I'm sitting here trying to make mocktails for everybody, and there's so many people who are thirsty that I can't make the drinks and deliver the drinks and keep up. So I need a robot. I'm like, all right. And so he like talked through, in 6-year-old speak, what his requirements were and what it needed to do. And we talked through like what the different modes of operation were, and he wanted it to be completely wireless and do some sort of homing thing. And we talked through like what might be hard about that, what might be easy. And so he ultimately decided he wanted to follow the black line and looked at different sensors and different tape and different lighting effects and all of this. And then a big part of engineering, learning engineering is communication, right? Because if you build something and you don't know what it does, then it's not clear that anyone knows or cares or can use it. And so he went to make this poster board, old school poster board. I don't even know if people make these anymore. And I realized he couldn't read. And I was like, well, I'm not making your poster. And so we just printed all the pictures of him working on this. And then he very helpfully drew us a flow chart to make sure that you understood the logical order of the steps and how this worked. And he had this like whole spiel about sense, think, and act and autonomy and all the things. And I think it really is, I mean, in addition to getting to show you Julian, you at this point might see him at any moment. We'll find out. But I think it is very much that learning engineering process, right? Of understanding your user, understanding your requirements, thinking about what makes this work. What are the risks? One of the risks was like if you fill the cup too full, then you tip the water over. He insisted on using real water and not ice, so we would like spill the water over, and so then we had to figure out how to make the container more robust to like daddy putting the cup in the wrong place and all these things. And so, I mean, it really is very much, and I always look for inspiration from the kiddos because um, they remember how to play and they remember to have fun when they're solving problems and to kind of look at the white space of like, how could I do that? And then you're like, okay, well, I can't do that because of this. I can't do that because of this. And when you tell an adult that there is a constraint, right, the adult gets mad or sends a mean email or says, per our previous conversation or whatever, right? And the kids are like, oh, okay, that's not possible. Let's try this other thing. And I think this idea of this iterative development and exploring the space and finding a way to get to the solution, and it could be a line tracking robot, it could be lots of things, right? And the point is, how do I deliver drinks quickly? And it does indeed go around here very robustly and autonomously and all the things. So our parties are fixed. Everything is great. Um, so just to recap a couple things I think Jim said, is, we're very into here in Lens learning analytics. We're very into this being applied and things that you can use to upskill for your current job, for another job. It's intended to be because it is so interdisciplinary. It is intended to bridge a lot of different possible career paths and intended to give you new tools and new skills in trying to solve the problems that matter to you. And I'll be more concrete about that as we go. So again, it's a specialization within LDT. So like the other specializations, you take 10 courses, which is 30 credits. You have the two foundation classes Jim told you about, three concentration classes, two methods, and two electives. It should apply, I think questions that I think you might have or that people might ask are, do I need to be an engineer? No. Do I need to have background in education? Also no. I think you should have intent that you care about making things that work and you're willing to explore and try things and revector and all of that. But I think your domain literacy and whatever your chosen major or profession or career happen to be, I think enriches the program dialogue, enriches the use cases that we use, and is all. I think something that you'll find is if you look at the defense applications and you look at healthcare, you look at financial systems, like anything that is high consequence really has their own special problems, but also a set of common motifs of failure modes and whatnot. Um, we are fortunate to be at Hopkins where we have all of these. I'm just going to stay with it, 15 divisions. I should have looked this up. I think APL has been very excited to offer capstone challenges and inspiration for projects, but also many of the other schools are also interested in being partners. And as we go and we understand what the people in the program are interested in, it gives us an excuse and an opportunity to make new connections and new friends. And we'll talk about capstones here in a second. It's worth noting that Gemini did not make up learning engineering. So there is a professional body called Icicle, which is an IEEE part of the IEEE organization, and they've been at this for decades and defining the field, defining tools. There's a textbook on learning engineering. It looks like this. I was hoping it was there. That's where I thought it was. And so we will sort of merge the theory and the case studies toward really practical things that you can take away and operationalize. And so, there are not so many learning engineering programs in the world. There are a few. I think these are sort of the five things that I think of as strengths of our program as we've designed it. The first is mission literacy, right? Where we're thinking about, you are bringing problems with you. You likely have some experience in your travels as a professional about, for example, somebody who has a great idea and it never materializes, right? Or you tried to implement something in healthcare and the data trust and IRB shut you down 5 times in a row, or you built a tool that technically is great and the users didn't understand it, or you ran out of money before you could actually implement the idea because the sponsor changed, or I mean, there's a million of these things, although they do actually cluster into nice categories. And I think we live in many of these spaces and our colleagues and friends, live in these spaces. And so, as we build the specialization, as we hear from you, I think we also will follow iterative development and learn from you. But, I guess our pledge is that we will bring mission literacy and or find mission literacy to anchor the work that we're doing. We really care about the capability that we're producing, right? And we know that humans are a big part, the creative partnership between humans and machines, humans and systems and operational environments, humans and operational environments. Like the thing that we care about is like, did you accomplish the goal? Did you have impact? And I like to joke sometimes the way you have impact is having lots of meetings and allegedly. And sometimes it is, coming up with a cool algorithm, and sometimes it is um, public speaking or what have you. But we really are trying to get to that goal. Um, I talked a little bit about Hopkins ecosystem and however many divisions there are a massive number of experts in a massive number of fields. And so we can help you to access those environments. Um, I think we come at this with humility, recognizing that we bring ideas to the table and pedagogy to the table, but also that it's really a degree that to me is really exciting because the magic is in that intersection, right, between education and engineering and between a particular mission and a goal. Um, and it's not about like, okay, we're gonna go take a bunch of math classes and we're gonna go take a bunch of history classes and we're gonna go do a bunch of this other thing, right? It's like it's drawn from traditions in education and engineering, but also, human system integration and cognitive science and science of learning and so on and so forth. Um, and I think along with that humility is this idea of the flywheel. So the flywheel is a mechanical device that stores momentum. And so the idea is that we go through this iterative cycle of um, imagining and building and testing and assessing and then doing it again and again. And I think that um, we launched the program with very strong foundations, but also with the expectation that the students who are in the program will have the opportunity to shape the next iterations of the program, right? And so one thing Jim likes to talk a lot about is AI as a creative partner. And so we experiment with like, okay, can AI solve this problem? Or are we offloading the critical factor that makes us human? Um, and so, sometimes we'll use AI in a way and you'll be like, whoa, that's no good. And then we'll kind of talk about it and think about it and organize frameworks so that you can assess in your travels whether something makes sense by whatever your objective measures are, measures of making money or doing good, or perhaps both. Um, we are along those lines, right? We have I would argue, stable draft curriculum. Um, and so we have the two foundations classes, we have the three concentration classes, and I'll show you these in more detail in the next slide. Um, Two methods classes, a capstone, two electives, and we're trading back and forth and thinking through which methods classes are most appropriate and which electives are most appropriate. Um, but it looks something like this, right? Um, so we start with principles of learning engineering, and thinking about this is a systems problem that's bringing together these different domains, talking more about the flywheels. Then we move into human AI teaming and adaptive systems, where we're designing and evaluating systems with AI augmentation, or I would say generally machine augmentation. I want to comment parenthetically that although we all talk about AI a lot right now, I think that this curriculum is enduring. And if we go through another AI winter, that doesn't, these skill sets are evergreen in that sense. The AI become applications of those ideas. And talking through how do we get evidence? How do we deal with uncertainty? How do we deal with risk? What's the risk versus impact trade-off? And then the Lens 3 puts these two things together, right? The learning engineering and the human AI systems, and really dives into that system integration, systems integration, human systems integration. How do we actually build a system and have a system and co-design the expertise of the human with the capabilities of the technology to produce the overall capability of the unified system. And you can think of a system you would design for a fifth grader is going to be different than a system that you design for an adult, and both might be valid technical solutions, but you have to understand your users and their motivation and capabilities and so on and so forth. Um, You can see here two methods classes. If you have a sharp eye, you'll notice that these are slightly different than the previous slide because we keep trading them back and forth. So we look at applied problem solving and learning engineering, where we do a guided review through case studies, likely in healthcare, engineering, and education, and then really get into more of the learning analytics and gathering evidence and thinking through sensors and what the ethics of, for example, using eye trackers or always on video might be, and how do we rapidly iterate, and how do we consider bias or spurious signals in appropriate ways? How do you scale these technologies up, right? I can put an EEG and look for causal inference in how your brain is processing signals, but I certainly can't do that across like every K-12 learner in the United States, nor should we want to, right? Um, that's a hot take. I stand by it. And then you have a couple of sort of Lynn recommended electives, and I'll stress that depending on what your background is, where you're headed, where you want to head, there's flexibility in the electives. But we wanted to provide two that we thought were important because I realized that in learning engineering is this large field, and we want to make sure that you are getting the core things that you need. And also exposing you to other things that we think will be a big help, even if they aren't absolutely required. So we want to give you at least a little flexibility to explore, if you want to go take a class in engineering or humanities or somewhere else in school of ed or what have you, that you can do that. Our LEN specific electives, one is capability analysis and requirements. So this is thinking about things like cognitive task analysis and frameworks for assessing capabilities. One of the big things there is if you ask an expert what they know and to describe how they do things, I think I've seen numbers anywhere from like 20 to 40% of the stuff that is in their brain, they're actually able to verbalize and put into words in a way that people can capture. And so what do you do? How do you deal with this? How do you think about this? And then Len 9 is looking at the foundations of deep learning and machine learning and statistical models and transformer models, LLMs, and thinking through a little bit of like, how do they work? I think we are not going to do proofs unless everybody begs to do proofs, and we can do proofs. But my expectation is that's not the case. And it's more of like a hands-on understanding, like what is an attention head enough that you understand where bias might creep into your system. And I think that when we've run through this before and in other contexts, people often are frankly kind of disappointed because LLMs all seem like magic until you see what they're doing. And then you're like, oh, yeah, it's just doing convolutions under the hood and picking things, relationships between letters and words, and it's fine. And I think once you know that, then you quit like thinking of Claude as your friend and just as a tool, and what does that mean, and all of that. And then we put our ideas, money where our mouth is, our ideas where our we anyway, you get to go use all these things, right? In this learning engineering capstone project where you go end to end in a real environment with a um, engineer or scientist or educator at Hopkins, or if you want to do a project um, at your current employer, we can look at that. I think some of you perhaps prefer that. I think many people in the engineering courses where we've done similar things will prefer to do things within Hopkins, so they don't have the intellectual property and uh, sort of rules, and they have some separation between their school life and their employment life. So either way, I think we are here to help you. And so you will have options. You will not be expected to invent one from scratch, right? Because we want to put you on a real project with real people who have stakeholders that need this thing to work. But we're not going to say everybody must go do thing X. And so you can kind of think of this as in just to make one other connection is in this applied problem solving class, we will go through these case studies and talk through, how might you solve this? What might you be thinking about? And then in the capstone, you will do it on a new on a new task, right? On a new problem space. Unless you sort of integrate all of this and also um, build out your portfolio and be able to demonstrate that you've satisfied the course and program learning objectives and so on and so forth. So I always wonder if I'm going to be able to talk for 20 minutes, and it never seems to be a problem. So, just three exemplars. So, these are all projects that have existed in the learning engineering space, sometimes with staff members, sometimes with students. So Pista was a project. We had 9 core students on this project. They were doing tactical AI decision support, helping military personnel understand if they walked into like a drug lab, what was likely being produced and what was dangerous. We did this all in an open source public context, which was also interesting. Um, and basically, what we wanted to do was to help the government understand like what ChatGPT would answer for you about these questions and like how good the vision models are and can you translate this from a video made in Sora to something that's happening in a high bay, for example, right? And so we went through this very rapid iterative process. For example, one of the things that was interesting here was really understanding the human needs. So often when you go into a lab and you don't know what's being produced, and it could be, mustard gas or a bioweapon or something, right? Like you don't just like stroll in there, right? You're in mop gear, which are like those bunny suits that you see on um, they're closely associated with Jack Bauer and all those things, right? And so people have done traditionally, engineers have done is they've built these very elaborate touchscreens for people to use. But if you're in a bunny suit, touchscreens are really hard, right? And they have all of the information you might want, but they have this giant finger and a giant stylus, and they're trying to stay alive, and it's just like the wrong cognitive load, wrong level of detail, and all those things. And so we worked through a lot of that and got feedback from some of these operators, and they were really excited. Echo is in a healthcare space. So I have a partner over in the School of Medicine who works primarily with limited English proficient patients. And she talks through some of the challenges that she sees in clinic. And she sees when there are language gaps, even with translators, where idioms get translated literally and um, some clinicians are very responsive and, kind of spend the time with the patient and try to build trust and draw them out. And some clinicians will, move more quickly, right? And it'll be like, does your head hurt? No. Okay, good. Right. And do you understand? And you nod and you're like, all right, good, let's go. And I know that sort of in general, like looking at the literature, there are cases where clinicians will just translate discharge instructions, like using an LLM and just hand them to the patient and be like, all right, bye. And you can think of this maybe not being the ideal thing. And then Teach Me Eddie is sort of the guy, our expert is named Eddie, and so we're being a little tongue in cheek here, but the idea here is how do we go from like a system based on really good retrieval to something that is more of um, a coaching tool and a learning tool where we're helping individuals level up and learn things in a pedagogically appropriate way. And I think something that's interesting is that, sometimes we need the really fancy stuff and novel research that's, coming out in 2025 or 2026. Many times it is just absent, right? And that evaluation. And so there's this opportunity to really um, make a big difference, even with some of the fundamental ideas that might be evident to someone who is an expert in one of these intersectional domains. Um, so, I guess I'll say in this wildly, awesomely formatted slide, right? I think our thesis here is capability matters. Capabilitymatters.org is our new website. If you find bugs, you should complain and we will fix them. That's how iteration works, is humility and speed. But really thinking about that interface between what a system requires of its humans, the technical demands of the system, and then the ultimate impact that things have in a society, in a real environment. And that's really what we're trying to go after. And so I know sometimes learning engineering is a bit of a um, mysterious term sometimes, and people use it in different ways. I think we have a strong hypothesis here, and have worked very closely with the Icicle folks and making sure that we're sort of staying aligned with the field, but also very focused on helping you level up and do things that matter. So I will pause there, I think. I have live demos and stuff. If nobody asks questions, you get to see live demos. Otherwise, I want to make sure that there's plenty of time for questions.
Amazing. Thank you, Will. I love listening to Will, period. And I know you enjoyed listening to him as well. Um, we do want to leave it open for Q&A, but there's something that Will said that I really want to go back to. Actually, there's a lot that Will said that I want to go back to, but there's one thing that really popped out for me. And he mentioned this term AI winter, right? And so historically, we've been through some cycles of AI at this point. There's been a lot of promise. It hasn't always delivered. But the point that I wanted to pick up on that I think Will was making is that the skills, the competencies and dispositions that you are developing in doing graduate work like this exceed any one technology, right? Really, what we are doing here is developing professional practices and habits of mind. So, learning engineering, there may be people called learning engineers. There are certainly learning engineering processes, right? And as Will is pointing out, it's a process. It's interdisciplinary in its approach. It draws from many, many different fields, many, many different disciplines. It applies the learning sciences. You develop a deep foundational knowledge of how human beings learn in different environments with different tools, using human-centered design processes, using human-centered engineering approaches to frame problems, to solve problems, to do that iteratively, and to collect data, to know how to collect data, to make informed decisions about whether your problem, whether the thing that you designed and developed to solve a problem is working, whether the thing you designed and developed to help human beings learn is helping them learn and develop. And then finally, doing all of this in the context of some system, as Will points out, right? This is about systems thinking. And it's a fundamental skill set that you're developing in a concentration like this. So the reason that I come back to that is because I think it's incredibly important in any graduate program like this. Because technologies, if you don't know, you will know, come and go, right? Many come and they never see the light of day. Many come into education and they fizzle out instantly. But what's much more fundamental are the skills and dispositions that you will learn, that you will practice and build beginning here and then for the rest of your career. So I think that's incredibly important to keep in mind. With that, I'll stop and open it up for questions and answers. Or open it up for questions. I guess there'll be answers.
And so the idea is people put their questions into the Q&A.
Or they can, I think they can open their mics, right, LEL, if they want.
Yep.
I
So if folks want to use their voice, you can raise your hand and I can give you access to your mic. You can also use the Q&A function. I did have one question that did come up in the registration form. Can you both maybe shed a little bit of light on what students should expect in terms of I'm losing my train of thought here, like laptop computer specs that they should have when coming into this program?
So Jim and I talked about this, and we concluded no, that I mean, a modern computer should be fine, And I think I'm certain that you can find a way to make us sorry for saying that, but like anything in the last, I don't know, 2 or 3 years should be fine. Like I mean, you probably want a computer and not like a Chromebook, but beyond that, Jim and I both use Macs, but certainly lots of people use Windows, and that's fine.
Okay, great, thanks. So we do have a question coming in here. And I'll read it out loud. So the individual is curious and they want to know how connected the program is to active learning engineering or ed tech initiatives at Johns Hopkins. And are there opportunities for students to contribute to ongoing research, pilots, or cross-functional projects while they're in the program?
Yeah, I mean, I think absolutely. I think in some sense with the capstone you are compelled to do such a thing. But I think there are lots of Hopkins resources. There are everything from like the what am I trying to think of? JHTV is maybe what I'm trying to think of, like the tech incubators and entrepreneurial things. Certainly, our case studies, some of the things I showed you are things that we do with our students now that, there is much need for help and lots of ideas that exceed our ability to implement them. So I think there are formal things within the program that will link you to those, and then there are additional opportunities if you have bandwidth and interest, and we can help you identify those as well.
What I would add to that is that part of this concentration, and Will was saying this earlier, there's a lot of tailoring that will go on here, right? So, depending on who you are and what you're doing and what your professional trajectory is, part of the work that we will do is to help place you in the right situations, right? Um, Often within Hopkins, not necessarily. And as Will was saying, they could be with your current employer as well. So, one important distinction to make is often we're thinking in terms of master's degree experiential education, right? So what we're talking about here is a focus on application. You're thinking about lots of concepts, lots of theories in class, and then you have opportunities to apply them in some professional setting. That's the strong focus, right? Now, we do have students who are also interested in research, applied research generally, basic research more rarely. There is not currently a thesis option in this program. There will be. So, just to draw the distinction, capstones are applied projects. Theses are usually considered original intellectual contributions, the kinds of things that wind up getting published as papers. So, we haven't launched with a thesis option. There will be a thesis option down the road. Whether there are opportunities for you to engage to become something like a research assistant, that's hard to say at any given moment because it depends on the opportunities that are there. It depends on, frankly, the research funding that people have, and whether they have funding to bring in master's degree students. Typically, that funding is reserved for doctoral students, for whom there's an expectation to do that kind of work so they can eventually go on um, to take academic positions. So both of these opportunities are there. There will be more opportunities in the application and the capstone space than there will in the research space at any given moment.
Anything else, folks? I did see another one in there, and I think we probably answered it during the presentation, but I'll just bring it up for the larger group. Will lend to include knowledge tracing as part of measuring learning?
I think that's where I would put it in Lin 2, between Lin 2 and Lin 3, as we build out the syllabi.
So I want to ask a couple of questions, Will. Um, so what kinds of do people need to be engineers if they're coming into this
No,
program?
no,
Do they need
Yeah,
to be
so
engineering adjacent?
no.
Okay.
So don't let the word engineer, like it's unclear if learning engineering, the term inspires people or scares people or what have you, but there are explicitly no like domain or major prereqs for this program. We will do design work. We will do some relatively gentle coding. If you have never written a line of code before, that is fine. Welcome to the age of AI. Everything is great. I think it's much more about the process and the ideas. Again, certainly you could use this as a springboard to go do something new. I think that a lot of these concepts lead very specifically to helping you to do whatever it is that you're doing better, right? And to be focused on what the ultimate outcome is, not optimizing for like good code or good ideas or what have you.
I've got one more for you.
Mhm.
So, if
Do
you're
you think I know the answers to these, or is it just that you're finding out about
I
them?
think you're really good at thinking about these things on the fly. Um, so if you're a prospective student and you're thinking about these three different concentrations, right? Learning experience design, AI leadership, learning engineering, what for you is it that makes learning engineering distinct? I would say first from learning experience design, but also AI leadership.
Yeah, I think that lens is really embedded in different problem spaces, and helping you to navigate these problem spaces where humans are an absolutely essential part of the system, and I think often an under valued or understudied part of those systems, which is why it's in the School of Ed and why we are so able to look at these big questions, because we have engineers, like we don't have the intellectual frameworks um, and tools in our toolbox to really assess humans and to understand learning paradigms and whatnot. And so I think being in the School of Ed, we get both, right? You get the systems thinking, you get the focus on the human. But I think characteristic of Lens is the outcome is often not the human or not just the human, right? There is some higher goal that someone has that might be, again, like we live in a capitalist society. It might be that our goal is to make money. It might be that our goal is to, deliver the best advertisement or whatever. And we're really, I think, what's exciting to me is that if you care about the human and their agency and their process and their autonomy and they're them able to actualize their hopes and dreams and all those things, like we give you those tools, but we are doing that in a way that you can get buy-in and investment in your ideas because you're anchored in that bigger problem space. And I think that anchoring in the mission in that capability is unique and is sort of our niche.
Thank you.
Jim, I have a question for you.
Sure.
Um, did you know that Forrest Gump knew about LLMs way back when?
I did not know that. And I
Yeah.
actually think I've seen Forrest Gump in the last year.
So if you go back and look, the whole movie, he's just going, Genai, Genai, just Gen AI the whole time. And like we all just missed it. But the whole movie, he was trying to tell us,
This
uh,
is why you all need to come to this program so you can
it's
listen
gonna
to
be great.
Dr. Rongel's jokes.
It's gonna be great.
There are 11 divisions, by the way.
Oh, neat.
At least that's what I see on Hopkins' page.
Nice. That's good to know. Now that I've recorded 7 times in this hour. If you guys do have questions, I think that to Jim's point about not needing to be an engineer, I think I am tremendously excited about this. I think this is an area that we've talked about for years and thought about and taught in and worked in. And I think being able to bring this together as an intellectual concentration and body of courses is going to be really amazing. I would say that um, if you feel psyched out somehow, you should not. And feel free to reach out and we can like run through your background and talk through some of the courses in more detail and make sure that you feel like you have the adequate supports. But you should certainly think of, I mean, I think all the specializations in LDT, but Lynn in particular, because it has a arguably scary name, is this do I want to learn to optimize these system capabilities and to think about the humans? And it's our job to help you do that. You don't need to worry if you can do that. Like it's an applied master's program, and it is, like Jim says, sort of designed around you to make sure that you are succeeding and as you go through the process.
Yeah, no, thanks everyone. I mean, it's 8 o'clock, and I just want to be respectful of everyone's time. So Dr. Gray Runkel, thanks for taking some time and sharing your expertise. Folks, I know we didn't really get much time for the admissions side. When I send the recording, I'll include all the admissions details that you need to know. But the big highlight is the application deadline is July 15th. And again, I'm the admissions representative lead for this program. So emails you've been getting, feel free to reach out. More than happy to jump on a Zoom with you if you have questions about your specific app. But other than that, I will go ahead and close out the session. Thanks, Dr. Diamond, as well. And we will see hopefully everyone in the fall. Thank you.